Question number 7 deals with in Newton's second law. The law is Newton's second law, force. There is an object, it has some initial momentum P, maybe 0 also. You apply a force, its momentum changes. Another possibility, there is an object, a cricket ball moving towards you. It is having initial velocity, you catch it, the final speed is 0, again there is a change in momentum. So, let there is an object with momentum P, you apply force F, and the new momentum is say P plus delta P. It has taken how much time? Delta T. Then as per definition, force is proportional to the rate of change of momentum. To be more specific mathematically, it is the rate of change of momentum with time. Both force and momentum are vector quantities. Every scientist, whenever comes out with the formula, need to have this value of constant of proportionality. In this case, this value, force is equal to constant of proportionality is 1. So, we need not write 1, rate of change of momentum. Momentum is what? Yes. Momentum is equal to, yes, mass into velocity. So, quite possible that mass varies, only mass varies 1, velocity remains constant. Second possibility, velocity varies, mass remains constant. Third possibility, both mass and velocity vary. Whatever it be, we can have two cases. Case number 1, when mass is constant. If mass is constant, you can take mass out, m constant. Then how you write it? F is equal to, if m is constant, you can take m out. It is m is equal to ddt of v. It is equal to what? F is equal to ma. This is 1. Second possibility, it's a velocity which is constant. If v is constant, you can take v out. Then F is equal to what? V into dm by dt. Let us try to understand what it means. Rate of a change of mass with time for a pipe, because generally you get these type of questions. For a pipe, mass coming out per second. From a tap, you get 1 liter per second. From a tap, you get 1 liter per second. How much mass is coming per second? 1 liter is how many kg? 1 kg. 1 liter bottle is 1 kg. So 1 liter mass is coming per second. We call it the volume flowing per second. You can change volume flowing per second to mass flowing per second if you know what? Density. So density of water is known 1 kg per liter. So they will give you a liquid coming out per second. You can find out volume coming out per second and then find out mass coming out per second. So dm by dt means mass coming out per second. You will have different numericals. 1, cricket ball, we can assume the mass remains constant. Second, a tap, water is coming out of tap with a constant velocity v. Then you need to find out mass coming out per unit time, that is dm by dt. So if you have a pipe, some water is coming out of this, you will have to apply force to keep it stationary. Agreed or not? How much force is required? Speed, velocity into mass coming out per second. Time with you is 4 minutes to write. Yes, numerical number 1 data given is what? Mass 20 in 10 power minus 3, U is equal to 300 meter per second, V is equal to 0, S is equal to 3 in 10 power minus 2.03 meter. Whether it's a bone or a ball, initial speed is U, final speed is V, final speed V is equal to what? 0. What you have to find out is force. So, step 1, V square minus U square is equal to 2AS and F is equal to MA. Yes, step 1, A is equal to what? If you put V is equal to 0, U is equal to 300, S is equal to 0.03, A is equal to what? Minus, yes, 1.5. How many of you are getting 1.5? Minus 1.5 meter per second square. Is it so? In tens per? 1.5 in tens per 6. How many of you are getting 1.5 in tens per 6? Let me write 1.5 into tens per 6 SI units, meter per second square. Negative sign means what? Retardation. We know this from the diagram. Initially it was having some speed, final speed is 0. So this is braking, retardation. Not an issue. F, you can write magnitude of F. We know it is braking. Mass of the object is how much? 20 into 10 power minus 3 kg into A, 1.5 into 10 power 6. Solve. Comes out to be what? 3 into 10 power 4 Newton. 3 into 10 power 4 Newton. Here, yes, not an issue. In the book, they have written to be minus, nothing to worry about. We have, through the diagram, represented that it is retarding a force. That is why what we find is only the magnitude. Fine. So, magnitude is 3 into 10 power 4. Nature is retarding. Fine. 1. Numerical number 3. Numerical number 3. Try numerical number 3. A force produces an acceleration of 16 meter per second square in a body of mass 0.5 kg. First experiment. And an acceleration of 4 meter per second square in another body. Second experiment. If both the bodies are fastened together, that means third experiment. Then how much acceleration will be produced by this force? You need to draw 3 diagrams. Diagram corresponding to experiment number 1, diagram corresponding to experiment number 2, and diagram corresponding to experiment number 3. What is common in 3 experiment? Force. So, given is when you apply force to object with mass m1, you apply force F. And what is the acceleration produced in the first case? 16 meter and mass is 0.5 kg. M1 is half kg, 0.5 kg. Acceleration produces how much? 16 meter per second square. This is experiment number 1. Can you find out the force F? F is equal to M1 A1. M1 is 0.5, A1 is 16. What you get is 8 Newton. 2. Second experiment. Another object, mass M2, same force of 8 Newton produces what acceleration? 4 meter per second square. Find M2. Force is equal to mass into acceleration. Force is how much? 8 is equal to mass M2 into acceleration 4. What you get is M2 is equal to 2 kg. Experiment number 3. Draw a diagram for experiment number 3. Go through the question. If you tie the two objects together, experiment number 3, both M2 and M1 are fastened together. M2 is how much? 2 kg. M1 is how much? 0.5 kg. Now you apply the force F. How much? 8 Newton. F is equal to M1 plus M2 into third experiment acceleration is A3. F is given how much? 8. M1 plus M2 combined together 0.5 and 2 kg. 2.5 kg. A3. Find A3. 8 divided by 2.5. 3.2 meter per numerical number 4. Try numerical number 4. Numerical is a stone of mass 5 kg. Numerical number 4. Numerical is a stone of mass 5 kg falls from the top of a cliff 50 meter high and buries 1 meter deep in sand. Find the average resistance offered by the sand and the time it takes to penetrate. Draw the diagram. Height of the building is what? 50 meters. This is a ground, and you can say sand. This is the floor, ground. This is the reference. So height of the building is 50. A particle or a stone of mass, yes, 5 kg. As it moves down, speed will keep on increasing. It will attain some speed. Just before hitting, let me say its speed is v. As it moves in sand, speed will decrease and final speed comes out to be what? 0. 1 meter deep in sand. This distance covered is how much? Say S2 is equal to 1 meter deep. Find the average resistance offered by the sand and the time it takes to penetrate. Anyone? Step 1 should be what? V, yes. Step 1 is to find V. Hint, school. Apply initial speed here. U is 0. V, you have to find out. V, U, it falls through what distance? 50 meters. And under the effect of gravity, acceleration due to gravity. Apply V square minus U square is equal to 2AS. To A 10 H 50. Comes out to what? 10 root under root 1000, that is 10 root 10. Approximately 10 into 1.4, that is 14.14. Approximately 14. But you can write in this format. Yes. Now you shift to this part, only this part. If you know V, earlier it was not known to you, now it is 10 root 10. Now you shift to this part only. Final velocity is 0, initial velocity is 10 root 10. It has covered distance what? 1 meter. Can you find out A, or by applying another equation, time t, 9th class? Try. Step 2. First we will find time. No doubt it is second part, but first we can find out time. Final velocity Vf is equal to initial velocity V, but yes, you will have to apply V square minus U square first, because A is not known to me. Vf square minus V square is equal to 2AS. Find A2. Find A2. Vf is what? 0 square minus V square, 10 root 10 square is equal to A2. I don't know A2. S2 is how much? 1. Solve and find A2. Yes. Minus 500 meter per second square. What you have to find out is retarding force. Step 3. Opposing force. Force is equal to what? Mass into acceleration. mass into acceleration. Find opposing force. F is equal to mass into this, only the magnitude. Mass is how much? Yes, 5 kg. A2 is how much? Magnitude, only magnitude, 500. What you get is 2500 Newton. Magnitude of opposing force is 2500 Newton. Here they have written negative means opposing force. Why there is a difference? Yes, we are using G to be 10, actual value is 9.8. That makes no difference to us. Step 4, find out time. How much time it takes? How much time it takes for the particle to from speed v to vf, or time of journey in sand. This part is sand. So journey time in sand. Step 4, v final is equal to v plus a2 into t. Final speed is what? 0. Initial speed in this case 10 root 10. A2 is minus 500 meter per second. Time t is equal to what? 10 root 10 divided by 500. Solve, comes out to what? Calculate, 1 minute for calculation. 10 root 10 is 14. This part is 14.14. So you get 14.14 divided by, yeah, 10 into 3.2 or 3.3, yes? 3.1, say 3.2, fine. 32 by 500. It is workable, approximately. Fine, if root 10 is 3.2, 3.2 into 10 is 32, 32 divided by 500, multiply and divide by 2. If you multiply and divide by 2, it is 64 by 1000, 0.064 seconds. Right? Approximately, not exact because we are using the value 10. It is approximate value.